addition with mixed numbers? Mixed numbers. A mixed number is the sum of a whole number and a proper fraction. Remember, a proper fraction is a fraction where the numerator is less than the denominator. So the top number is smaller than the bottom number. So here are some examples of mixed numbers, 12 and 5/11. Notice that the top number, 5, is smaller than the bottom number, 11. Or 2 and 2/9. 2 is smaller than 9. But these are not mixed numbers. 3 and 7/5, because the 7 is greater than 5. So the top number cannot be larger than the bottom number. It looks like a mixed number, but it's not the proper form. It's not a mixed number. Okay. So what are we going to do if it is in that form? If the fractional part of a mixed number is improper, we're going to change the improper fraction to a mixed number, and then we're going to add the whole numbers together and attach the proper fraction. Okay, so I know this lesson is on addition with mixed numbers, but before we get to that, we need to talk about this particular topic first before we get to that part, so that it'll make the transition easier when we get to this issue when it comes up. Okay, so we are going to talk about adding mixed numbers, but it's going to come up in just a little bit. Okay, as always, like maybe you weren't done writing that down, maybe go back and finish writing your notes on your notebook, and then come back when you're done. Okay, here's our first problem. Write as a mixed number 11 and 9/4. Okay, so it looks like a mixed number, right? 11 and 9/4, but the problem is that 9/4. 9/4 is not a proper fraction, it's an improper fraction. So we're going to have to change the 9/4 into a mixed number. So that means, well, how do we change an improper fraction to a mixed number? That's right. We divide the bottom number into the top number. Divide the denominator into the numerator. So go ahead and divide 4 into 9. And then how many times does 4 go into 9? Right, 2. And then you're going to get a remainder of 1. So we're going to divide, since 9/4 is improper, change it to a mixed number. Divide 4 into 9, you get 2. 4 times 2 is 8. And then the remainder is your numerator. And the original denominator stays the same, so that's going to be 2 and 1/4. Okay, so that's what 9/4 is equal to. And now we're going to add the two whole numbers together. So it's going to be 11 plus 2 1/4. So add the 11 and the 2. So 13 and 1/4. That now is a mixed number because it's a whole number and a proper fraction. So I know there's no symbol in between, but it does mean sum. I said earlier on the previous slide that it was a sum of a whole number and a proper fraction. There's no sign in between, but it is a plus. Sometimes people think, oh, that means multiplication. It's not 13 times 1/4, it's 13 plus 1/4, but we don't write the plus sign in this format. So it's 13 and 1/4. Okay, let's try another one. 22 and 8/5. You might want to pause the video and try that one on your own, and then click back on play when you're ready to see the worked out example. Okay, so 8/5 is improper. We're going to change that to a mixed number. Divide 5 into 8. 5 goes into 8 once, and there's a remainder of 3. So that gives us 1, and remember just kind of like flip our remainder over the divisor, so 1 3/5, and then add the two whole numbers together, so that's 22 plus 1 3/5. So add a 22 and 1, 23 3/5. Okay, that wasn't too bad, right? Okay, let's move on. Here we go. Adding mixed numbers. Here's our procedure for adding mixed numbers. Number 1, rewrite the problem vertically. And this is an option. Some people prefer to leave it horizontally, but we're going to write it vertically here. Rewrite the problem vertically, aligning the whole numbers and fractions. Then we're going to add the fractions and add the whole numbers. Now when we add the fractions, just like in previous videos, we're going to have to find the lowest common denominator and change the fractions to equivalent fractions if the denominators are different. Okay, and then we're going to add the whole numbers. Now, number 3, if the fraction is improper, if it's an improper fraction, then we're going to have to change that to a mixed number, just like we were doing in the previous examples. And then we could add all the whole numbers. Okay, so let's write it. Here's our first example of this type of problem. 8 5/9 plus 4 2/9. We're going to go ahead and write it vertically. Again, you might want to pause the video so you can write the notes down in your notebook. Write the example down in your notebook so you can work it out. And then click on play when you're ready. Okay, we'll write it vertically. Now, do we need to find equivalent fractions? Or can we just go ahead and add the two fractions? Right. The denominators are already the same, so we could go ahead and add the fractions. 5/9 plus 2/9. Since the denominators are the same, we could go ahead and add the numerators. That gives us 7/9. And 8 and 4 is 12, so 12 7/9. We don't need to worry about step 3 because the fraction isn't improper. So that answer is 12 7/9. Okay, we'll have some better problems coming up. Yeah. Step 3, not necessary because the fraction was not improper. Alright, next problem. Now we could already tell here on this problem that the denominators are the same in this one as well. So we won't have to find an LCD yet. Okay, so let's write the problem vertically. Again, you might want to pause, write down the problem. Okay, so let's rewrite it vertically. And we could add the fractions and the whole numbers. So 7/11 and 8/11 is, well, 7 plus 8 is 15, so that would be 15/11. And we could have a 15 and 9, 24. All done? Oh no, right? Not done. 15/11 is improper. So since the fraction is improper, we're going to change it to a mixed number, and then we could add all the whole numbers. So now we could go ahead and divide 11 into 15, and that gives us 1 and 4/15. And now we could add the 24 and 1. So that gives us 25 and 4/15. Okay, not too bad. Each problem just we add a little bit more to each one. Let's go on to the next one. Oh, now we could see on this problem our denominators are different. Okay, so again, pause the video, maybe write down the problem. Kind of know the steps already. Let's get started. Rewrite the problem vertically. Okay, so we're going to have to add the fractions. So we're going to need the LCD for 12 and 8. Well, maybe you could see 12 and 8. What's the LCM for 12 and 8? What's the smallest number that 12 and 8 both divide evenly into? Remember, not what goes into 12 and 8, but what do they go into? So maybe you could see it in your head, or if you do the tree for both of them, 12 is 2 times 2 times 3. 8 is 2 times 2 times 2. So the LCD will have the greatest number of 2's that occur in either row and the greatest number of 3's that occur in either row. So the most number of 2's that occur in either row would be 3. The greatest number of 3's that occur in either row would be 1. So 3 2's and 1 3 will be our LCD, which is 24. And maybe probably most of you saw that 8 and 12 go into 24 without doing that. But it's still a good habit to know the process, because sometimes those denominators get kind of large and it's hard to see what the LCD is. Okay, so we're going to rewrite it with 24 being our new denominator. So 72 and blank over 24 and 54 and blank over 24. So it's proper form to put the whole numbers in front of the fraction, but if you didn't write the whole numbers in front and just added it where it was, it wouldn't be a major issue. But proper form is to rewrite it with the whole numbers in front of that fraction. Okay, so 12 times what number is 24? 12 times 2, so we have to multiply the 5 times 2. And then 8 times 3 is 24, so 7 times 3, multiply the top number by 3. So that gives us 10 on top and 21 on the top for our numerators. Now we could finally add the numerators. So now we've added our fractions, and we could add our whole numbers. 126. Okay, almost there. Our fraction. Right, you probably noticed it's improper. So since the fraction is improper, we're going to change it to a mixed number. So divide the 24 into 31. So that goes one time, and you should get a remainder of 7. So that's 1 and 7/24. So you got 126 plus 1 and 7/24. So our answer is 127 and 7/24. Yeah, you got it. go on to another problem. Pretty similar to the last one. Probably same type of problem. You might want to just go ahead and pause, work this problem out on your own, and then click back on play when you're all ready to see the worked out problem. Okay, here we go. Rewrite the problem vertically. We need to find the LCD for 14 and 10. So we're going to add the fractions and whole numbers. So 14 is 2 times 7. 10 is 2 times 5. So the LCD is going to have 1, 2, 1, 5, and 1, 7. Sometimes people will make a mistake and put 2 2s. But it's only 1 2, because remember, we only write down the greatest number of 2's that occur in either row. And that's only 1. So 1, 2, 1, 5, 1, 7. Now, what happens is if you use too many numbers, then you're no longer using the lowest common denominator. You're using a common denominator, not the lowest one. And then that just means more reducing at the end. Okay? So it's not tragic or anything like that. It's not going to mean that the whole problem's wrong. It just means more work for you if you don't use the lowest common denominator. Actually, in some books, some older books, they even taught people just to go ahead and multiply the two denominators, 14 times 10, to get 140. And that's how they told you to find the LCD, which is not, they just said, well, actually, they didn't even use the word LCD. They just said, that's a common denominator. But here we're teaching you a proper way of finding the lowest common denominator. Okay, so you should get 1, 2, 1, 5, and 1, 7. So that multiplies to be 70. So that's your lowest common denominator. So now we're going to write them as equivalent fractions. And then we're going to add. So let's see, 14 times what number is 70? Well, see, look at over to the right. 14 is 2 and 7. 2 times 7. So then look at the LCD. The LCD is 2 times 5 times 7. What's missing from the LCD that the 14 has? Sorry. What's missing from the 14 that the LCD has? Just the 5. So 14 times 5. I don't know if you got what I just said there. 14 is 2 and 7. Okay. Hopefully I don't distract you with all these lines. 14 is 2 and 7 are circles. So here's a 2, cross out the 2 and 7. What's left? The 5. So this has got to be 5 right there. Okay. I'm going to kind of erase that now. It's probably a cleaner way to do that, but I don't know. Okay, the next one is 10. Well, that one's easy. 10 times 7 is 70. So 7 times 7. So on the numerator, on the top fraction, we get 45. And the denominator, the numerator of the top fraction, we get 49. Now we could add the two numerators. (94 over 70). And we get 35 and 94 over 70. Okay, now we have a choice. We could either, well, again, you notice, let me backtrack there. Our fraction is improper, but it also could be reduced. So you do have a choice. You could reduce first. You could reduce first and change it to a mixed number, or you could change it to a mixed number and then reduce. Let's probably just change it to a mixed number first. Okay, so let's do that. So 70 goes into 94 one time with a remainder of 24. So that gives us 36 and 24 over 70. But right, we're not done. Let's see, what goes into both 24 and 70? 2. So we can divide them both by 2, so that gives us 36 and 12 over 35. So if you did it any differently, you might have divided by 2 first. You would have got, it still would have came out to be the same thing. So no worries. Alright, I think we've got one more example here. 521 plus 612 and 8/15. So let's go ahead and rewrite the problem vertically. And then we're going to add the fractions and whole numbers. Well, to add the fractions, well, there's only one fraction, right? Well, there's no fraction on the top. I mean, you can think of it as a 0 up there. Well, what's 8/15 plus 0? Or what's any number plus 0? Same number, right? So we could just add the fraction. So it's 8/15 is our fraction, and then add our whole numbers, and then that's it, because we don't have an improper fraction. That one was a little bit too easy. Sorry about that. Well, that's it. That's it for this lesson. And I'll see you here for subtraction with mixed numbers. That's the next video. So, have a good day.